Okay, in this video, we're going to be putting together the do-it-yourself gauge pod that I designed. So let's get this box open, take a look at what's inside, and then we'll talk about our sponsor, NextPCB. All right, so let's get this box open and see what we got here. All right, so that is one of these. Now let's check and see if the stepper motor actually fits, since this is something that somebody else designed and not like a off-the-shelf one. Let's just go with a brand new one. All right. So the drill hole for this one is too small. Okay, so it does fit. Let's take a moment to talk about NextPCB, a PCB manufacturer located in China that is not a broker. They actually produce their own in-house, unlike a lot of the guys that just resell the stuff. So they offer trial PCB orders where it's free. The manufacturing's free. All what you have to do is pay shipping, and then they have very affordable rates on everything else that they sell. Now, they also produce some new software called NextDFM that lets you check Gerber files. So, say you see a video on YouTube where some guy like me is designing a gauge pod, and you go, "Hey, I want to try that out," and they put their Gerber files out for free. But you're like, you know what? This guy, he could be an idiot. Let me take a look at it before I get it manufactured, which could be very well true. So you open it up and you look at it in next DFM, because this is the Gerber file now. You don't actually have like the schematic and everything. So you pull up the Gerber file, take a look at it, and you just go DFM analysis, and we see that, oh, hey, look, the copper edges are wrong. And my copper edges were wrong. This is actually the file I sent to them. I didn't rig this up for it. So you go and click check to see why it's wrong. So the clearance that I had was 10.9 mils, while the recommended clearance is 15 mils. So that way you don't get, when it does the route around the edge, it doesn't tear copper or anything like that. So helps prevent any issues there. So it makes sense. I made a design mistake there. And so and it's never got I never caught this till now. So definitely very useful software here. It caught an actual design mistake that I made. I didn't rig this up for the video. I thought I was going to have to rig up a mistake to show it, but no, I had made one. So there was actually a second mistake I made. You'll notice if you watch the live stream of me designing this, I said, oh yeah, I'm doing 50 millimeters. Well, I did a 50 millimeter radius, not a 50 millimeter diameter, so it's actually 100 millimeters. I also would have caught that in Next DFM, because the second one down, so you got layer count and then you have dimensions, and you'll see that it's 100 mils minus the route. So it makes it a little bit smaller, but yeah, that's exactly yeah. I made a design mistake, and both of these I could have caught them very easily using the software, had I taken a good look at it before I sent it out. So I definitely recommend the software that they designed if you're going to order with uh, if you're going to order with NextPCB, because it's already pre-programmed to all of their slots. So yeah, let's get back into the build now and continue on. And we're going to go from the circuit board design here now to the actual, from the breadboard to the circuit board. Okay, so here what I'm doing is I'm first just putting a little flux on the board, just giving a nice little coat to everything on the backside, and then I tinned the pad for the oscillator. So then I'm going to use hot air here to put it on there. I'm only using about 25% airflow at 370 Celsius there for putting that on. And then just put the resistors on. All that you got to do is tin one of the pads, and then set your resistor down. Use your pin, let it flow into place, and then do the next pad. That way you get it down there nice and flush. If you tin both pads, then you'll get kind of crooked or have it a little bit lifted off the board. flip it over, do the same thing. Just put a little flux on the whole board there, and then just do one 10 one-let pad at a time. And then just put our resistors, LEDs, and then the LDO or voltage regulator on there, and the capacitors. So now that we have all the surface mount components on, we're going to start putting on these through-hole components. Take a little bit longer to get lined up there, but when you're building a circuit board like this, you're going to want to start with basically your smallest, lowest footprint items and work your way up. So that way you're not working around something taller. So that's why the stepper motor goes on. Really should go on last. I know I kind of went out of order and put the LEDs on last because I didn't have them out in front of me. I had to turn around and go grab them. I did go a little bit out of order there putting on the LEDs. The LEDs would have been what I was going to do right before the motor and stuff, because they are a little bit higher. And then we're just going to clean it off with some rubbing alcohol here. Okay, so now we have everything assembled. Normally, if you were just to power this up, nothing would happen other than the backlights would come on, but because the microcontroller is blank. But the microcontroller that I used on this one, I actually had pre-programmed it when I was doing this one. I thought I was having problems programming it, so I took it off, put another one on, and then realized I was just an idiot and uploading the wrong thing. But yeah, so I have two already programmed ones. So this one's already programmed, but we're going to power it up, take a look at it, and then I will actually show you how to program it. We'll wire up the Arduino and actually program it again, so that way you guys know how to do it. But let's take a little test here now that we got it all put together and see what happens. All right, and there we go. It's running. So does the exact same thing as it did in the other one, where we just have this script where it's just stepping it all the way one way and then all the way back the other direction. And obviously, I didn't use the green LEDs that were on the BOM. Like I said in the live stream when I designed this, I just grabbed that one because it was the correct size. It wasn't actually the part number I was going to ultimately use. So yeah, pretty straightforward putting it together. I think what people might find the hardest to get on is either going to be the microcontroller or the crystal oscillator on there. So those will really be, people's biggest challenge. Maybe the LEDs too, because you can melt them if you're not careful. But yeah, so let's take this thing and program it now, and then in a future video we'll actually make a useful script for it. So this one we're just I'm gonna show you guys how to get it programmed, so that way if you want one of these, so that way you can help design some useful software for it, or if you just want it for the solder challenge portion of it. To wire this in, we're gonna go C, as in the one labeled C on here, which this number right here correlates to what pin of the microcontroller it actually goes to. So that way, if you are applying this to a different project, it's still helpful. That way you can come back and reference this later. So yeah, so C, which is clock, goes to D13. D13 on your Arduino Nano, because this is what we're going to use as the in-circuit programmer to program the AT. So you're going to use an ATmega to program another ATmega, pretty much. Plain and simple, not too complicated. So yeah, just get a good look at this, write down whatever you need. I'm going to move it out of the way so that way I can work here. So this is going away, but yeah, definitely you can just pause the video there to refer to it. So let's go ahead and get started with this. I'm just going to go ahead and tin all the pads that we need and zoom it in a little bit here so that way y'all can see what I'm doing. So yeah, when I typed this out, it didn't all come out perfect. But again, this is the very first prototype board anyways. It's gonna get replaced here eventually because I didn't do any reverse polarity protection on here, and I really want to make these actual little headers. Haven't I haven't finished writing the software for it, so I'm not sure exactly how I'm going to communicate between this one and there's going to be a master board to control these. So that way you can have like more than one of them doing something at a time. So we need ground, we need clock, we need the master in, we need the master out, and we need reset. So reset's being used as if it's chip select on these. That's how these work. So we'll just go ahead, put that in there. Okay, so now we just gotta hook them up to our Arduino. So we're gonna start with ground is our first one. Ground is just GR and D on here, and then we're doing the C, which goes to D13, which is this top one right here. This one's a little worn out. I'm gonna grab a different one. This one can just go in the trash. All right, and we're gonna go with. So this one is yeah, this one's C. So C is 13. D13. All right. Then MI goes to D12. And MO goes to D11. And then the last one, which is reset, goes to D10. So that's all there is to wiring it up. Let's switch over here into Arduino IDE so I can show you how to burn the bootloader. Okay, so first thing you're going to do is go into File, and then go to Examples, and you're going to go to Arduino ISP, and click it. Okay, so then you have your Arduino already hooked up to the computer. You're going to select the correct COM port, so it's COM port 10 for me, which is connected to this Arduino Nano. While you're connected, you need to have it in the AVR ISP and just upload this sketch to the Arduino. So now the Arduino has the sketch on there, so now this can act as our in-circuit programmer. So now we need to go same COM port and just change it to Arduino as ISP, and then go back to Tools and click Burn Bootloader. And once you click that, it will program this with the new bootloader. I'm going to go ahead and do that. Okay, so now we've burned the bootloader to it. So now we need to actually program it with the sketch. So let's get the correct sketch opened up. So that's going to be the stepper motor sketch right here. And let's go, and we're going to use, again, Arduino as ISP. Instead of, we could program it two different ways, but we're just going to do this where we're going to upload using programmer, just because we're already wired up that way, so it's just easy enough to do that. All right, and see, now we're back to running. So super easy way of doing it. With the bootloader burned to it though, we could have wired up through the UART connection that we left on there and been able to program it that way. But since we were already wired up this way, it was just the easiest way to do it. All right, so again, I just want to say thank you to our sponsor NextPCB for sponsoring this video and making it possible. Hopefully you guys enjoyed this and learned something from it. It helps show you how, because between the live stream and the reassembly here, it really shows you how to go from a Arduino project and a breadboard into a semi-finished product here. This one's still for prototyping here, so that way I just not sure exactly what I'm going to do for the final programming. I left both serial and SPI connections here, so that way I can communicate it with it either way. I know I'm not going to do CAN bus, at least not for this project. Maybe I'll do a CAN bus project here in the future. But for this one, we're either going to do something over UART, over serial, or something over SPI. Okay, so I have all the components to complete 3 more of these. So if you want one that's a kit to assemble yourself that comes with all of the components, I can sell you one of those for 25, and that'll include shipping. As long as the shipping's not, as long as you don't live in like Alaska. So if it's shipped here in the United States, I can include shipping on that. And then I have 5 more just blank ones that I can just send you the BOM with, and you can order the components. It would be cheaper to actually get one of these. I am selling at a slight profit here, but that's really just to mostly just cover shipping. But yeah, you can probably source all the components a little bit cheaper than what I'm pricing it at. So just an offer, but yeah, if you just want one of these, even if you're not going to assemble it, if you just want it to just have something, just pay shipping and it's yours. And then on these, I can put it with a little baggie of all the components for it. I'll label the capacitors so that way you know which one's which, or I'll just put the capacitors on there so that way. But that ruins the solder challenge, because that's the whole point of this, is to get some of these technicians that need to practice some of their finer pitch stuff to get one and practice on it. So I don't know. Maybe I'll just label the capacitors, but I'm not going to assemble a whole board for you, because the whole point of this is so that way you will learn how to do this. Same with programming it. You need to learn how to program it. I'm not gonna send it to you with a pre-programmed microcontroller on it. So that way you learn. This project's that way you guys learn. So just let me know if there's any interest in any of these. You can help me develop software to make these actually useful. I will definitely make these smaller, and once we get the software all figured out, I will put headers on here instead of this. But definitely, if you have any interest in getting one of these, things that we can make this useful for is we can make them as actual gauge pods for a car. Or we can use them for simulator games, so with like SimHub or something like that. So yeah, just let me know if there's any interest in these. I have no idea if people are interested in these at all. And yeah, once they're gone, they're gone. I'm not going to order more of the prototype board. I'll do more once I do the final design. But like I said, the Gerber files will be on the GitHub, and so will the sketch, so that way you can go out and get them manufactured by our sponsor NextPCB or whoever you want to take it to. So yeah, just you guys know how to get a hold of me. You can either comment down below, you can check out the Facebook group, or you can find my email in the About section of this channel. So yeah, just let me know if there's any interest in these. I'd rather get them out to people that'll use them than let them collect dust around here. So yeah, this is just a prototyping iteration of this project. I still need to add reverse polarity protection to it, and then finalize how I'm going to do this and actually put headers on there instead of just these blank pads. Because if this is just going to be used for the in-circuit programming, then I can just make that a header which just has to reset, and I can drop off the S, so that the S is slave select for actual SPI. While it programs through SPI, but it uses the reset pin as if it's slave select to do that. So I can drop that one off once I decide what I'm going to do. But these very well, I'm probably going to use SPI to communicate to these. So these will all be little slave modules on the SPI network, and then just have one Arduino controlling all of them. So basically it'll just send a percentage to them, and then the motor will move to whatever that percentage is. So hopefully you guys found this useful. Definitely, if you want to play around with the sketch, if you want to write some script for me to just test on one of these for you and send you what happens with it, just let me know. So yeah, I hope you guys liked the video, and I'll see you guys in the next one.